Hi again, everyone. Okay, we've learned igneous and sedimentary rocks. Now it's time for us to learn metamorphic rocks. And we're going to begin by taking a look at the ESRT's scheme for metamorphic rock identification. That's page 7 of the Earth Science Reference Table. Just want to give you a brief overview. If you take a look, you'll notice that the metamorphic rocks are divided into two basic categories, which are foliated and non-foliated. I will explain those terms later. We do have the grain sizes indicated. We do have the composition. Now we're not talking about chemical composition, we're talking about mineral composition, what minerals make up these particular rocks. Now here we have the fourth column, which is type of metamorphism. Now you're going to notice that the type of metamorphism is divided into two types, regional and contact. All right, those will be explained in a few minutes. Comments, these are important because you'll notice that it kind of says what rocks turn into what rocks. So shale can turn into slate. And you'll notice that gneiss can come from a variety of rocks, obviously. You'll notice that sandstone turns into quartzite. Bituminous coal turns into anthracite coal. So these are the metamorphic rocks. And this comment section does include, in some cases, what rock is the parent rock that turned into this rock. And finally, we have the map symbol that we would use on a diagram to indicate which one of the rocks we're trying to depict. Okay, so just a little overview here. Now we're ready to go to our rock and mineral packet, pages 17 and 18. So let's take a look at what we got here. Now the first thing I want you to understand about metamorphic rock is that meta in Latin refers to change, and morph means form, means change form. That's why they use the term metamorphosis to describe a caterpillar turning into a butterfly or a tadpole turning into a frog. Now, so that means these rocks have been changed. So these are rocks that have changed, have been altered by intense heat or pressure. All right, those are the things that can change a rock, heat and pressure. Now remember, if you squeeze matter tight enough, it does get hot. So pressure does also create heat. All right, but here's the important thing you have to remember, that when you're forming metamorphic rocks, or when the Earth is forming metamorphic rocks, there is absolutely no melting of that parent rock. Because think about this, if the rock had melted and then solidified and became a new rock, what kind of rock would that new rock be? Answer the question. All right, well, in reality, if there was melting, the rock formed would have to be igneous, because igneous is the only rock that forms from liquid material. So instead of melting, what's happening is what we like to call recrystallization. It's a change in the form of the minerals. And actually, it can even cause the creation of new minerals. Like garnet forms in this way a lot. So the parent rock will have no garnet whatsoever, but then the metamorphic version of that rock, it'll change into a metamorphic rock which actually has garnet. So yeah, you can actually create new minerals without melting, which I think is really cool. Now let's look at this simplified diagram just to kind of like put what we said into a diagram form. You can have tremendous pressure exerted by these overlying layers, thousands of feet of rock, or you can have tremendous heat being given off by the magma in the earth. So you can have this tremendous heat or this pressure. Either one of those can cause the recrystallization and metamorphism of rock into new rock. All right, now let's take a look at the two basic types of ways in which this happens. So the first one is called regional metamorphism. Now regional metamorphism is when the rock is altered by the tremendous pressure, and remember, pressure does bring heat with it, but it's primarily pressure, the tremendous pressure of mountain building processes. So if you have two pieces of continent pushing into each other, well, that's a tremendous amount of pressure. And what it can do is it can squeeze the rock in the middle so hard that that rock changes into new rock. That's what we call regional metamorphism. Now, if you recall back when we learned about climate, we learned about the orographic effect, which had to do with the climate of mountain ranges. Windward side wet, leeward side dry. That was called the orographic effect. Oro. Well, the process of mountain building like this is called orogeny, and that's a term you'll see in the ESRT a lot. The process of mountain building is orogeny, and orogeny does create metamorphic rock in the middle there. So now we're going to have to go to our ESRT for a minute, or you will, and I'd like you to go to your ESRT, check the fourth column, and locate and record the rocks that are formed only by regional metamorphism, only in this way. Pause the video, record your answers, and we'll see if you're right. Okay, the rocks that are formed only by regional metamorphism are slate, phyllite, schist, gneiss, and anthracite coal. Those are the 5 answers you should have put. Only regional metamorphism. Now, let's go a little further now. Let's take a look at the other way metamorphic rocks form, which is called contact metamorphism. Now, that's when the rock is altered by the intense heat, and I mean heat alone, no pressure, of the adjacent magma or lava that's next to it, it's in contact with. Okay, so let's think about this. Let's analyze how this works. A represents magma coming up from in the earth, tremendously hot stuff. Now, if you take a look at the top of page 7, this polka dot design here is supposed to represent the rock known as sandstone. So that would be sandstone. And B, these sideways lateral dashes, that represents the rock known as shale. Now, where A meets C, now this zone right here, if you look right along here, this zone right here, and on this side as well, right here, this zone there, that's where the heat of this magma is altering the sandstone. So the heat of the magma is altering the sandstone. So if you take a look back at your metamorphic rock scheme, which rock is formed from sandstone being altered? The alteration of sandstone creates which metamorphic rock? Locate it, pause the video, put your answer right here. And the answer is quartzite. Quartzite is a really boring rock, actually, and it's formed by the metamorphism of sandstone. Okay, now we're going to hold off on this one for a moment. Now remember, pressure always creates heat. Now, which type of metamorphism involves both heat and pressure, but mainly pressure? Please write down what type of metamorphism that is. And your answer is regional metamorphism. So now we're going to go back to the ESRT for one moment, and you are going to locate and record the name of the only rock that is formed only by contact metamorphism. Which rock or rocks are formed only by contact metamorphism? And your answer was hornfels. Okay, so now here comes my tricky question. What rock is going to be formed where B meets A? So this contact metamorphism right here. Okay, so where B meets A. Now, I'm not going to lie to you. There's a trick here. So be careful. So check your ESRT and try to figure out what would be the rock that would form where B meets A. Okay, I imagine you've probably been struggling with this one pretty much. Now, a lot of you kids probably went to the ESRT and located, and you said shale turns into slate, it must be slate. Well, the answer is no, it's not slate. It's not slate, and I'll show you the reason why. Because although, yes, slate does come from shale, slate only comes from regional metamorphism. So, what could it possibly be? Well, the only rock that it could possibly be, if you eliminate all the other ones, it's not made from dolostone or sandstone, it would have to be hornfels. All right, contact metamorphism, it has to be hornfels. And that is a very tricky question. I hope you got it right. All right, but like I said, most kids, they go right. Okay, well, the answer is hornfels, people. Okay, so that was careless of me. So hornfels is your answer. And we are going to stop right there. We'll have a second Metamorphic Rock video afterwards. But right now, we're going to quit right there because it's getting long enough. Put any questions in at the end that you might have. And thanks for paying such close attention.